Hi friends, we are back to our next lecture of linear algebra where determinant was going on. Now we want to go for some important result in determinant which are very much important for CS and NET and IIT examination. If you followed this kind of important result, then I think in your exam it will be helpful and some trick you can use for your exam and it can be faster for yourself. So let's start with this important result. First one, if A is an n cross n matrix, okay, where A plus B, AB 0 0 0 up to so on 1 A plus B, AB 0 0 so on 0 1 A plus B, AB and so on 1 A plus B. Now what is the determinant of this matrix? The answer is A to the power n plus 1 minus B to the power n plus 1 upon A minus B. Now you can say how. So for this how, we'll go for the process. You know, this is A plus B, this is AB and this is 1. If A is 2 and B is 3, then A plus B means 5, A into B means 6 and this is 1, 5, 6, 1. So 5, 6, 1, 5, 6 and 1, 5. This is the small version of your previous result. Am I right? So our actual answer would be A power 4 minus B power 4, A minus B, 2 power 4 minus 3 power 4, 2 minus 3. This answer is 5. And normally you can see, the answer is 65. And normally your answer is also 65. So you have to remember it like this way. Our formula is A power of n, A power of n plus 1. A power of n plus 1 minus B power of n plus 1 divided by A minus of B. This is our actual answer. Okay. Next result, this is also important for CS and NET purpose. If determinant of A is looking like here is, in a principal diagonal all the elements are alpha and off diagonal all the elements are beta, then what is the determinant of this matrix? We don't know what is the, it is a n cross n matrix, but we don't know it is n is even or odd. Now for n is even, determinant of A is equal to, you have to remember it, alpha square minus beta square to the power n by 2 if it is even, and if it is odd then alpha square minus beta square power n minus 1 by 2. It's okay. If it is even, then n by 2, because you have to divide by 2. If it is not even, how can you divide? You have to remember like this way. And if it is n minus 1, why? If it is odd, like 3 by 2, it doesn't mean. So 3 minus 1 is 2 by 2, so it's mean. So you have to remember it's like this way, that if it is even, that is n by 2. If it is odd, then n minus 1 by 2. And in your here, alpha square minus beta square. So take an example, like this is a matrix where principal diagonal it is alpha means 1 1 1 1, there is alpha and 1, and it is off diagonal, so beta is equal to 2 2 2, so beta equal to 2 and n is equal to 6. Okay, so by formula, since n equal to 6 it is even, so formula is by n by 2, so alpha square minus beta square power n by 2. Now you can see this is 1 square minus 2 square power 6 by 2. Why? Because alpha equal to 1, beta equal to 2, and alpha square beta square means 1 square minus 2 square, and n is equal to 6, so n by 2 means equal to 3, so 1 minus 4 by 3. Why? 1 square is equal to 1, 2 square is equal to 4, so 6 by 2 is equal to 3, so minus 3 power 3, so minus 27 is our actual result. Okay. Next important result. Let A be a matrix of order n cross n, where entries are either 1 or minus 1. Then the value of the determinant by is divisible by 2 to the power n minus 1. Okay. Always you have to remember that if the entries are either 1 or minus 1, and it's matrix of order n cross n, then it is divisible by always 2 to the power n minus 1. If n is 2, then 2 by 2. If it is n is 3 minus 1 minus 2, 2 power 2, that 2 to the power 2, that is 4. For an example, if A is 1 minus 1 minus 1 1, all the entries are 1 and minus 1, and determinant value is minus 1 minus 1, that is equal to minus 2. Minus 2 is divisible by 2 to the power n minus 1. here n equal to what, 2, so 2 to the power 2 minus 1, so 2 to the power of 1, so 2. I know minus 2 is divisible by 2. It's our result. Now some important definition. First definition is minor. In a previous already I have done, already I said in previous lecture what is minor, but if I give you definition then you can understand properly. Like minor is denoted by mij. Okay, I is the number of row and j is the number of column. The minor of an element aij, minor is always denoted of a element, means minor of this element, minor of this element. Okay, minor of an element aij is the determinant. Minor is a determinant. Okay, it's a value of the square submatrix of order n minus 1. Means if it is a matrix of order 3 cross 3, then the minor is of order 2 cross 2. You have to remember it. Minus 1. If it is order of 10, then the minor is of order 9. And obtained by deleting the row, ith row and jth column. Means if we want to find the minor of this A11, so you have to delete the first row and first column. If you want to find the minor of this first row, second column, that is A12, first row and second column you have to delete. And then A21, A31, A23, A33, this will be our minor. So minor of A11, what is the minor of A11? So you have to delete this. So this is in minor. So A22, A23, A32 and A33. Okay, the value is, you have to find the determinant, and you know how the second order determinant will be done. Now cofactor. Cofactor means just in front of minor you have to add some add his sign. Means, you know, for a matrix every position have sign, and the sign is actually written by minus 1 power I plus j. I is the number of row and j is the number of column. And cofactor of A11 means minus 1 power of 1, so plus minor of this first row. Cofactor of the A12, that is for this element, cofactor is for this position minus 1 power of 1 plus 2. So this is equal to minus 1 power 3. So minus 1. So minus into his minor. So you can see minus 1 and his minor, and this is our actual value, and so on. You can find all this. Now next, very important, is adjoint of a matrix. Okay, most of the question will related this adjoint of the matrix. Okay, what is the definition of adjoint? The transpose of cofactor matrix is adjoint. First of all, you have to find the cofactor matrix, then their transpose is called the adjoint. Okay, already you have done what is the meaning of cofactor. Now for every element you have to find the cofactor. For a small a11, the cofactor is capital A11, for this capital 12, and find all the cofactor, then his transpose is our actually adjoint of a, which is denoted by adj of a. Also there is a shortcut method, it's not necessary, you can find like this way. Next example, A is a matrix 5 6 3 2 4 9 6 5 2. It's okay. Then normal method to find the adjoint of a matrix is, you have to find the cofactor and also his sign, plus minus plus minus plus minus plus minus plus. Okay, and their transpose here 30 minus 37 50 minus 14 3 minus 8 11 42 minus 39 8, and so on. And if you transpose, then get a matrix, and by shortcut method this is also same, these are same. Next, some important properties. adjoint of A into A, which is equal to A into adjoint of A, and which is determinant of A into I. What? Adjoint of A into A and A into determinant of A, which is equal to determinant of A. Sorry, adjoint of A into A into adjoint of A, which is equal to determinant of A. How? A into adjoint of A, which is equal to determinant of A. Sorry, this is the result. From this, A into adjoint of A is equal to determinant of A. So A into adjoint of A by determinant of A equal to I. So you can write A is here. So I by A means A inverse. So A inverse equal to adjoint of A when determinant of A is non-zero. Okay. And A is a non-singular matrix of order n. Then determinant of adjoint of A, we have to write determinant of A power of n minus 1 power 1. That means determinant of A power of n minus 1. And adjoint of A, which is equal to determinant of A power of n minus 1 square, and so on. For the n numbers of k times of adjoint, the actual answer is determinant of A power of n minus 1 power of k. And for the n, if we write adjoint of, and so on, adjoint of A, and which is n time, then our value will be determinant of A power of n minus 1 power of n. It's very easy. Okay. And here we'll complete our lecture, and determinant will finish, and your next lecture will go for the rank, inverse, and so on. Okay, bye.